All right, guys, so today we're going to talk about water and its phases. So remember a water molecule, H2O, is one oxygen and two hydrogen atoms, and it's a polar molecule, so the oxygen is slightly negative and the hydrogen side is slightly positive. Now, when water is moving around in its different states, it acts differently, the speeds at which it moves are different, and it does different things. So we're just going to visit the three states that water can be in, because water is very unique in that it's one of the only forms of liquids that we can find in all three states on Earth that when it's in a certain state acts a little bit differently than you would expect. So before we can even talk about that, we should just revisit the states that water can be in. And the first state we're going to talk about is water in its liquid state or liquid phase. So when water is in its liquid phase, the molecules are moving freely. So think of liquid as very flowy. Think of the water molecules also being very flowy. They're able to move about freely, they bump into each other, and they can fill any container that you put it in. Now, we also know that when water is in its liquid state, it can dissolve a large number of substances, and that's why we call it a universal solvent. It is also able to be in its liquid state in the greatest range of temperatures. So it can be super duper cold because at 0 degrees Celsius, which is like 32 degrees Fahrenheit, that's when water freezes, but it's also when water can start to melt and turn into a liquid. And that can be super duper hot. So at 100 degrees Celsius, the water starts to boil and turn back into a gas. And so super, like it can be very hot, but still be in a liquid form right below 100 degrees Celsius. So from 0 to 100 in Celsius, that's a large range of temperature. The speed at which the molecules move is going to be medium, so they're moving about, free flowing, very casual. The next state is water in a gas state. So, like liquid, water in its gas, like a gas state, can fill any container that you put it in. The molecules are moving very, very quickly in a gas state, and they're very far apart. So think of when you take a pot of boiling water and you're going to make like noodles or something. When you put that pot of boiling water in your oven, it's in a liquid state. It heats up to 100 degrees, and you start to see all this action. It's starting to boil. That's because it's above 100 degrees, and now it's turning into a water vapor, that's steam. The molecules, when it's in that steam or gas state, are just moving real fast and they're super far apart. The last state is water in a solid form, and when water's in a solid form, we call that ice. So when water freezes, it expands or gets bigger. Um, the molecules, they vibrate back and forth, but they do not move to different positions. They're kind of stuck in that position. So the molecules, the temperature is lowering, they're going to move slower, and eventually they stop moving, and they form these really nice bonds. Remember, that's a hydrogen bond. And because these special bonds are formed, they make a nice lattice pattern, and you'll notice in these pictures we have a nice beautiful shape, and in that shape there's a lot of empty spaces between the bonds, and that empty spaces actually makes it so that ice or solid water is less dense than liquid water, and that's why ice floats at the top of liquid water. And the speed at which the molecules move is very, very slow. So they're vibrating, but they're not moving. So why does ice float? So it's very important to remember that ice is less dense than liquid water. And remember, density means how much matter is taking up a space. So when water turns into a solid form, the space that it takes up, like it'll expand, but there's less space being taken up in the area. So we have this picture of ordered molecule structure of frozen water. You'll notice it's a nice pattern, and all that purple, that's empty space. So it expands and it has a lot of empty space, so it makes it a lot less dense. If you were to look at the liquid water molecules, you wouldn't see all that empty purple space. It would be all filled in. The molecules would be like a lot closer together. It's more dense. So the liquid water, all this would float on top or be underneath the solid water. Um, so have you ever put a water bottle into a freezer so it gets cold faster? And we all want to do that. We want nice cold water, and then something happens and we forget about it. So what happens when you forget and you go back and check on it? Sometimes it can do this. So the water bottle, and this looks like it was a glass soda bottle, was put in a freezer, and then it expanded as the liquid water or soda um, froze, and it shattered the container that it was in, because while it was a liquid state, it fit its container, but when it started to freeze, the water molecules started to make those nice bonds. And remember that in a solid state, it makes that nice lattice like pattern, and in that pattern there's lots of empty space, so it takes up even more space when it freezes, and it broke the container. So that can happen. And then it's really important also that water is less dense than liquid water. So think of the winter, there's lots of animals that depend on ice floating at the surface. So fish, they survive on the fact that ice is at the surface and the liquid floats on top of the liquid water, because they live in that liquid water underneath. They're not frozen like fish ice cubes, um, because that ice helps insulate and keep that water warm. So if you remember, water has that high heat capacity, so it's able to retain heat for a longer time. So it's, even though the water is cold to us, it's still warm enough for the fish that live in that liquid water to survive, and that ice just helps insulate and keep that heat, whatever heat is in that liquid water, in. And that also helps animals that depend on like those animals underneath surviving. So like the polar bears and the seals and the penguins, they need to walk on top of that ice to be able to get to the fish that live underneath. So we can see water in all three of these phases or states in our water cycle. So just to review before we talk about our water cycle, if you start with a pot of boiling water and you put that boiling water on top of your like stove, and we heat that up. It starts with liquid water, and when liquid water changes into a water vapor or a gas, we call that evaporation. Now, gas, those water molecules, they can cool down eventually. And as it cools down, it's going to change back into liquid water, and that's condensation. And that's actually how our clouds are formed, is liquid water evaporated, turned into a gas, into water vapor, and that water vapor cooled down and actually turned back into liquid water droplets. And those liquid water droplets are suspended in air and form clouds. And then when the clouds get too heavy and there's too much liquid water droplets suspended in air, they fall back down, and that's your precipitation. And eventually that can all freeze back over and turn into solid ice. So you can see liquid water, my molecules are not in a pretty pattern, they're all everywhere. And then it's going up into gas, and my molecules are farther apart, and that cools down, and there's solid ice, and the solid ice is the one with a very pretty pattern. And you'll notice that in that pretty pattern, there's lots of empty space. So we have the water cycle. There's three phases: evaporation, where my sun heats up the water, and the liquid water, that can be any liquid water. And that liquid water, the molecules move faster and faster, and eventually it'll get so warm that they evaporate and turn back into a gas or water vapor. That water vapor is going to rise. And as it rises up into the atmosphere, those water molecules are going to start to cool down, because the higher you go up in the air, the cooler the atmosphere is going to be. So once it gets too cool, the water vapor is going to turn back into a liquid, and it's going to form our clouds. And then eventually, all those water droplets that are suspended in air in our clouds is going to get too heavy, and it's going to fall back down as precipitation. And then there's runoff, where that water runs off the surface and underground all the way back to our large body of water, just to restart. And that's why we call it a water cycle. Now, for your homework, other than taking these notes, is to identify the phase or the state of water in the images below. So you have three bottles or containers, and from those you have an image of the molecular arrangement of the molecules. So the first bottle on the far left, we have the molecules are arranged in a pattern. The middle bottle has a bunch of water molecules. They're not in a pattern, but they're pretty densely packed together. And my last water bottle has two water molecules that are far apart. So you just need to identify which is a liquid, gas, or solid, and write that below your picture. And then we'll talk about it tomorrow in class after warm-ups.